Hi and welcome to this 11-part Unity game development tutorial series, brought to you by the Fraser Coast Council. This tutorial series builds upon the skills learned from the previous tutorial series, so if you have little to no experience with Unity development and C# programming, then I recommend completing the previous one first, as this series will skim over some of the fundamental aspects of developing with Unity. To watch the previous tutorial series, see the link to the playlist in the description of the video. In this tutorial series, you will learn how to create the mini golf game that you see here. The game supports multiple players that can compete across multiple levels, leading up to a final scoreboard displayed at the end of the game. Much like the previous tutorial series, it shares many common aspects of Unity development, including physics colliders, user input prefabs, and UI, but will take a deeper dive into the programming aspects of creating more complex systems that persist between scenes. I will also show you how you can upload your game to Unity Connect so you can share your game with family and friends online, which they can play from anywhere on any computer via a web browser. To play my completed game in your web browser, see the link to Unity Connect in the description of this video. As of recording this video, Unity Connect games only seem to work on the Google Chrome web browser. So if you are having any difficulties loading or playing the game, then I recommend downloading and installing Google Chrome. In part 1 of this tutorial series, we will start by setting up the basic controls and visual feedback for changing the direction that we wish to putt our ball. In the previous tutorial series, we covered the downloading and installing of Unity Hub and Unity. So we're just going to skip that process and start off just by making a new project here. So we click New. We'll be using Unity version 2019.3.8 F1 and just here select 3D template. Set the project name to anything like mini golf, and you can just put it anywhere in your documents or whatever. Select folder and then just click create. Also in our previous tutorial, we covered the basic layout of the Unity editor and the functions and tools and how they all work. So in this tutorial, we're just going to run through it without much explanation. So if you're looking for more detailed information, you can go back to the other tutorial. So just to start off, we'll go Window, Layout to something more kind of standard. Sorry, Window, Layouts, Default. That's what we want. Just go to a default layout. I can just move this like that. I think the first thing we'll do is we'll get the asset packs that we'll be working with. So just go into Google and type in Kenny game assets. Just click on the first result. Kenny is someone who produces a variety of 3D and 2D game assets, all for free, completely free to use, both personally, commercially, for education. All of that, so it's a really great resource. We're going to be using two different packs, so just to find the one we want, just select by 3D up here, and the two packs we're going to be using is the nature kit, and we're going to be using things like rocks and trees, mushrooms, and other kind of natural obstacles for our courses, things for the ball to bounce off or block the path of the ball, of the golf ball. So middle mouse click on that to open it into a new tab. And I'm just going to find the other one. I think it's on page 2, which is the mini golf kit. Middle mouse click on that. So here are all the pieces. It's a modular set, meaning that all the pieces just snap together, which is really convenient. And this is an example of something that you could make with this kit. And to download it, just click up here, and this will pop up, and you can just save that into your downloads. And while that's downloading, we can go over to our nature kit. Here's an example of that, what that looks like. These are all the pieces, just same thing, download and hit save. Once they're both finished downloading, you can right click and extract. Pretty sure Windows has a default unzipper, but this is just WinZip. But yeah, so you just want to extract the zip file with whatever program you use, and it will give you this folder, the extracted folder. So we can go into here, we want to go into models, and we want to use the FBX format. So now we see all the pieces. So then go back to Unity and then open up the folder so we can see it here. Actually first, before we drag that all in, let's right click, create folder, and we can just call this models, and go back here, Control A, and then click and then drag them all in. Those will import. And in fact, let's also, because we're going to be bringing our nature ones in there, let's create another folder in there. Let's just call it mini golf, and then Control A, and then Control click on the folder we made to deselect it, and we can drag those all in there, mini golf. And let's create another folder called nature. Open up the nature folder, back to our downloads folder. If you want to, you can just delete the mini golf stuff. We don't need that anymore. And then we can do the same thing for the nature kit. Extract, select models, FBX, Control A, and drag. Now we're not necessarily going to be using, or you may not necessarily use all of the models here, but it's just easier to drag them all in. If you were to make this for a mobile game or something, you want to keep file sizes small, you might remove the ones you weren't using, but all of these models are each very, very small, so it wouldn't make much of a difference. Now with all the assets imported that we could possibly ever need, we'll go back to our mini golf folder, and we can find they provide 2 balls, but we only need 1. And what we're going to do is we're just going to keep reusing the same ball for each player, but just moving it back to the start. So we can just drag this ball in here. And the reason why I'm using this ball is that the ball that was provided in this pack is scaled to fit well with all the pieces, including the holes at the end and the tunnels and all of that kind of stuff. So it's good that we use this ball. And first step is to add a rigid body and a sphere collider. So the rigid body is important for all the physics, and the sphere collider is responsible for the collisions. So we're going to need something for our golf ball to fall on. If I hit play now, the ball will just fall forever. So let's just create a little testing ground by right-clicking in Hierarchy, 3D object, and Cube. and in the scale up here, we'll set that to 0.1. Seems okay to me. Yep. And if we just move out, and we can just set the Y position to 0. And then if we hit play, the ball will drop, but our camera, yeah, we can see our camera is a bit far away, but the ball fell and it stopped here. So we need a way to be able to control our ball, apply force to it as if we were putting it with a club, and also set the direction of where we want to putt it and have some visual feedback to that, and so on and so forth. So we'll stop the play mode so that when we make changes they're not reverted, and we're going to make our first script. So let's go into the assets folder, right click, create folder. You can call this scripts, and then in the scripts folder, right click, create C# script, and we can call this ball controller. And while we're at it, we can rename this instead of ball red, let's just call it ball. And then let's bring our ball controller and attach it, dragging it over like so. So let's go into our ball controller, hit edit, and that will launch the IDE. So we can just start by getting rid of all of this. And the variables that we're going to need is a reference to the rigid body. We can just call the rigid body ball. And we need a private float angle. And we're also going to need a public float, meaning we can access it in the inspector. We need one called max power. On the awake, meaning before update, we want to get a reference to the rigid body, the ball rigid body. So ball equals get component rigid body. Whoops. And another thing, just a little tip, is we need to set the ball dot max angular velocity to something like, I don't know, 1,000. So max angular velocity limits how fast the ball can spin, and for our ball to move quickly, it's going to need to be able to spin quickly, and the default max angular velocity is too low and will really limit how fast our ball can go. So if you didn't set that, then you'd be trying to make the ball, applying lots of force to it, and make the ball go as fast as you can, and it won't be able to go faster. So that's important. And then we'll go into update. So update, we'll call the update function here. We can get rid of these access modifiers here, just because these are Unity methods, and I just like to do that to differentiate it from my methods. it is private by default without the access modifier keyword being put there. So we need to check for three things, three different kinds of inputs. So if input dot get key, now key down only happens once when they put the key down, but get key will be called every single frame while the key is down, which is what we want for turning the ball. And we want to specify a key code A, so the A key on the keyboard for left, and we want to do one for the right being D, so A and D, and then we can copy this again, and then we need one to actually putt the ball, and for this we're going to putt the ball when we release spacebar. So while we're holding spacebar down, it's going to charge it up, and then when we release, that's when we apply the power. So we want dot get key up, key code dot space. Great. So while we're holding the A key, we want to, because it's going left, we want to say angle plus equals, so adding to angle, time dot delta time. Now, because this is in the update, this is going to add 1 every second, but we want to be able to adjust that. So we're going to specify a public float change angle speed, and we're going to increase it by change angle speed multiplied by time.delta time. And actually, because it's A, we want to subtract, because it's going to be in the negative direction, meaning left is negative and then right is positive, and we would add it here. But rather than writing the same code twice, what we can do is we can have a method, and I'll just show you what that would look like if we were to do it twice, except this one would be adding instead of subtracting. Now, just to make things cleaner, and just in general, I don't like to keep loose code in the update method, the update function, because it just gets really messy. So I like to kind of keep everything in separate methods. So we'll call this method, we can call it change angle, sorry. So we can call this private void change angle, and it's going to take a integer of either +1 or -1, and we'll call that direction. So then what we can do is we can actually take this and we can pop it in there and just set that to plus equals. But then what we can do is we can multiply that by either +1 or -1, which will make it go in the positive or negative direction. So for A, we want to change angle -1 and negative direction. If we're pressing D, we just want it to be in to the right, being the positive direction. Now, if you go and run this, you're not going to be able to see much, but what we can do is, and what we will need to do, is provide some kind of indication of which direction the ball is facing. So for that, we can actually use a LineRenderer, which is a component. So going back to our Unity project, on our ball object, we can add a component called LineRenderer. The LineRenderer will need a material. So let's go into our assets folder, create a folder called materials, create material, and let's just call this line material. And for the shader, we're going to choose unlit color. Go back to our ball, scroll down on a LineRenderer, select our material, and drag it into materials here. Now this line is very big, and you can see here if I change this color, we're going to get different colors. So let's just make that red for now, something quite obvious. And on our LineRenderer, we will need 2 positions, which it has by default. And we want it to be kind of like an arrow sort of pointing, like not really an arrow, but just to show direction. So we can actually make it go thicker and then thinner. So we can add a key, and we can edit, and we can set the time to 1 being the end. And if we bring that down, you can see kind of, forms a sort of arrow sort of kind of look. And then we want, I think it's flat, I think flat. I don't know, we can change that later. But of course this is far too big. So let's move this down a bit. Something like that. We can fix that later in terms of positioning, and then use these little editor curve things to set that. We've got the general kind of shape. So what we have to set the start position and the end position for the line. So to see the angle change, or to see a visual representation of our angle changing, we will need to make our LineRenderer react to that. So let's go back to our code, and just down here we'll be calling the LineRender method that we'll create. So let's create a private void, and we can call it render line, or we could call it set line positions, or whatever you want. We can call that, we can say, we can get update line positions, update line positions. Just like that. We will need to get a reference to the LineRenderer. So let's make a private LineRenderer, and we can just call it line. And we will need to get reference to that. So line equals get component LineRenderer, like that. And then down in this method we can start setting those positions. So line dot set position, 0 is the first position, and we just want it to be set to transform, this transform as in the ball, transform dot position, and line dot set position 1. We want to set that to transform dot position, this position, plus quaternion dot Euler, and we set the x to 0, the y to angle, and the z to 0, multiplied by vector 3 dot forward, which is just 1 in the z, and then semicolon here. So quaternions are quite complicated in how they work, so don't worry about that. But what we're basically doing is that we're taking our position and then we are multiplying the global forward vector forward, or in a positive direction, by this Euler quaternion, sorry, by this quaternion, and that gives us a position of 1 in front in the global z direction from the current position. And if we don't want it to be 1, we can set it to something else by just simply multiplying it by, and we can just have a public float here, public float line length, and we can multiply by line length. Just hit save like that. And we need to make sure we're calling this every update. So we can just say update line positions. Oops, I keep doing that. Line positions, like that. So if we go back to our editor and set our line length to say 0.5 and our change angle speed to 40, and then hit play, we can now see when I press A and D, our line will move around. And we can play around with the thickness here. I'd like the arrow to finish off at a point. So if I drag this down, you can see it comes off like that. So if I edit it, you can see the value is exactly 0. You can enter it as 0. And as for the maximum value, I might have to for the max value, I want it to be the same size as the ball, which is 0.75. Sorry, 0.075. I click off that. I'm pretty happy with that. Could be smaller, could be bigger, but that's just showing us the direction that we want to fire or putt our ball in. Now we're still in play mode, so we want to save all those changes that we just made to our LineRenderer. So with the ball selected, we can right click on LineRenderer and click copy component. Then we can stop it. And then we can right click on LineRenderer again and click paste component values. And we've got it back to the way we wanted it. And we can just click save here. Save.